This video is for Algebra, Section 8.2, Dividing Monomials. Okay, today our learning goal, the learner will apply knowledge of the quotient of powers, the power of a quotient, the zero exponent, and the negative exponent property to simplify monomials. So in the last section we learned about monomials and we worked on multiplying them. In this section you will be dividing. So our first vocabulary term is a quotient of powers. Again, if you're looking at it, you should notice this is something to a power divided by something to a power. If you do that, if they have the same base, like A and A, they have the same base, you can just subtract the exponents. So again, if I want to give you an example, if I had x to the 10th over x to the 4th, that would be x to the 10 minus 4 power, which is x to the 6th. Okay? Power of a quotient. So we have something divided taken to a power. That just means you take this power through to anything in there. So again, we talked about this before. If I had 1/2 to the 4th power, I would take that 4th power to each thing. So I would have 1 to the 4th power over 2 to the 4th power, which is 1 over 2 times 2 times 2 times 2 would be 16. This is going to be the easiest one you have, zero exponent. Any number or variable to a zero exponent, anything to a zero exponent equals 1. So I can put all kinds of junk in here, and 15, and LMNOP, whatever you want. If it's all to the 0 power, whole answer is 1. Okay, so that's the easiest one. The one that's probably the most difficult in this section, it's not really that hard, it's just more work, is the negative exponent property. If you have a number to a negative exponent, to have it simplified, everything has to have a positive exponent. So when I have a negative exponent, I put it in the denominator. If there's nothing, if it's not a fraction already and there's nothing else with it, that means you have to put a 1 on the top, and this goes to the bottom and becomes a positive exponent. It also works in reverse. If I have something with a negative exponent, so I have 1 over something, or I have, a whole long fraction of things, but I have a negative exponent, to make that a positive exponent, you just bring it up to the numerator, and it becomes a positive exponent. Everything else stays the same. So again, so if I had x, y over z to the negative 4th, you could bring this up to the numerator, so it would be x, y, z to the 4th, because it would positive. And the other one was if I had x to the negative 3rd over y. If I had that, I could rewrite that. This negative exponent would go to the denominator. Since there's nothing left to go on the top, I would put a 1 on top. It would be x to the 3rd y, because it stays positive then. Okay, those are the main properties we'll be using. Prerequisite skills, some things you should already know how to do. Basic multiplication, division, addition, subtraction. Everybody should know those by now. Simplifying fractions is another one. With some of these problems you're going to have, you need to make sure you know how to simplify them correctly. Alright, and we will go ahead and start on our example problems. So number 1 on the first page. We have 5 to the 5th over 5 squared. So we have the same base, so the base is going to stay the same. And I'm just going to subtract my exponents, which gives me 5 to the 3rd. So that is the quotient of powers. Number 3. We have p to the 5th, n to the 4th, over p squared n. And you may want to write a 1 there to remind yourself. These match and those match, so it's basically two little problems. So p to the 5 minus 2 and n to the 4 minus 1, which is just p to the 3rd, n to the 3rd. Okay, number 5. We have x to the 5th, y to the 3rd, over x to the 5th, y squared. Again, use the ones that match, so x's go together, so x to the 5 minus 5 power, and y to the 3 minus 2 power. 5 minus 5 should give you 0. 3 minus 2 should give you 1. Anything to the 0 power you should remember is just 1, so it's times something, so it just basically disappears. And I don't have to write that 1 power, I could just write y. Number 7. We have xy to the 6th over y to the 4th x is what they wrote. I'm going to rewrite it in the right order, so xy to the 4th. That may help some of you. So again, these have a 1 power. So I have x to the 1 minus 1, y to the 6 minus 4. 1 minus 1 is 0. 6 minus 4 is 2. Anything to the 0 power is 1, so it doesn't matter anymore because it's times this. So my answer is just y squared. Alright, number 9. Actually, I'm going to clear my page so I have more space for number 9. Number 9, we have 4p to the 4th q to the 4th over 3p squared q squared, all to the 3rd power. And it's your choice. You can either take this 3rd power through to everything in here first, or you can try to simplify this before you take the 3rd power through. I'm going to try to simplify it before I take the power through. You can do it either way, you get the same answer. 4 over 3 I can't simplify. I can't divide that, so I'm just going to leave it there. I'm going to get rid of that fraction mark. And then I have things I can match up. P becomes to the 4 minus 2 power, and Q becomes to the 4 minus 2 power. Keep everything else there. And we simplify that again. 4 minus 2 is 2, and Q, 4 minus 2 is 2. So at this point I could take everything to the 3rd power. So I would have 4 to the 3rd power over 3 to the 3rd power, and p to the 2 times 3, q to the 2 times 3. 4 to the 3rd is 4 times 4 times 4, which is 64. 3 to the 3rd is 27. P to the 6th, q to the 6th, and that's it. Number 11. We have 3r to the 6th, s to the 3rd, and then 2r to the 5th, s, all to the 4th power. And since I did this one with simplifying it first and then bringing the 3rd through, I'm going to do this one the other way just to show you an example of each. So I'm going to take that 4th power to everything first. So 3 to the 4th, r to the 6 times 4, s to the 3 times 4, and 2 to the 4th, r to the 5 times 4, and s to the 4th. And again, you can do that either way we did the first one or this way, it doesn't matter, you'll end up with the same answer. 3 to the 4th means 3 times 3 times 3, which would be 27, times another 3, which would be 81. R to the 6 times 4 is 24, and S to the 3 times 4 is 12. On the bottom, 2 to the 4th. 2 times 2 is 4, times 2 is 8, times 2 is 16, so 16, R to the 20th, and S to the 4th. I cannot simplify 81 over 16. I can't divide them both by the same thing, so I'm going to leave those alone. 81 over 16. And then R to the 24th minus the 20th, and S to the 12th minus the 4th. So again, R to the 4th and S to the 8th. And that's it. That is the first page. So moving on to the second page of the study guide. Number 1 on the second page, we have 2 squared over 2 to the negative 3rd. And then again, there's a few different ways you could do this. It's your choice. I could say these have the same base and subtract, so I could do 2 to the 2nd minus negative 3, which becomes plus, so 2 to the 5th. Or you could have said, well, this is a negative exponent, I need to bring it to the top. So I would bring it up and it would become a positive exponent. So I'd have 2 squared times 2 to the 3rd, and there's nothing left in the bottom, so I don't need to put it at the bottom. And then I would have had 2 to the 2 plus 3, which is 2 to the 5th. Either one, I got the same answer. You can do whichever way you choose. It doesn't matter. Number 3. P to the negative 8th over p to the 3rd. I prefer to do kind of like this first way just because I think it's a little bit less steps. It's one less step. You can do it either way. So I would do p to the negative 8th minus 3 comes plus negative. That's p to the negative 11th. So I need to get rid of that negative power, so I'm going to switch it to the denominator. Don't forget, you have to put a 1 on the top because you need something to hold that top. You have to have something there. So 1 over p to the 11th is your answer. Number 5. We have negative x to the negative first, y to the 0 power, over 4w to the negative first, y squared. All of this stuff is to the 0 power. So if you remember that very easy one we had, anything to the 0 power, it's just 1. So the top becomes 1. And then you should see the only thing I really need to get rid of, I can't have that negative exponent. So to make it positive, it's going to move up to the numerator. So I don't have to write the 1 anymore because it'll be on the top. And I don't need the 1 power, it's just w. And 4y to the squared stays on the bottom. And that's it. And I'm going to clear the page and move to number 7. Number 7, we have x to the 4th, y to the 0 over x to the negative second. Y to the 0 is just 1, so I can get rid of that basically. And I could say x to the 4th minus the negative second, which is x to the 6th. That's it. On to number 9. Number 9, we have 3st squared times u to the negative 4th over s to the negative first, t squared, and u to the 7th. Alright, first thing I would do is get this 2 through my parentheses. 3 squared is 9, s squared, t squared, u to the negative 4th, all over s to the negative first, t squared, and u to the 7th. At this point, I would say, well, this one's got a negative, this one's got a negative. They have to switch. This has got to go to the bottom, this has got to go to the top. So that's what I'm going to do. I'm going to put that s to the first right here because it becomes positive when I put it on the top. And then t squared, u to the 7th, and u to the 4th would be down here now because when it moved to the bottom, it became a positive 4th power. So now I've got rid of all my negatives. I'm going to combine some of these. 2 plus 1 is 3, so s to the 3rd, t squared, over t squared, u to the 7 plus 4 is 11. T squared on the top, t squared on the bottom are going to cancel each other out. So my answer ends up being 9s to the 3rd over u to the 11th. Alright, and number 11 is our last problem on this page, and it should be the very easiest problem on this page. If you've looked at it already, you probably already have it solved before I can even write it down. 8m to the negative first L. Everything in the parentheses is to the 0 power, correct? It makes it very easy. Anything to 0 power, my answer is 1. Alright, and that is the end of section 8.2 video.